Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. This is the last chapter from Math 1, which is System of Equations, Matrix. So first of all, let us see 6.1 on the type of matrix. So we can have a row matrix, a column matrix, a square matrix. So this is a square matrix where you can see the number of rows and the number of columns is the same. For example, this is 3 by 3 matrix. Number 4, you can have a diagonal matrix where you only have entries on the diagonal part and all the other entries are 0. Number 5, you can have identity matrix. So what is identity matrix? This is when the diagonal part is 1 and all other entries are 0. You can also have a zero matrix where all the entries are zeros. Next is upper triangular matrix where you can have all entries below the diagonal part here is equal to 0, and you can have a lower triangular matrix where the entries above the diagonal part are all zeros. Next, let's see the operations on matrix. So you can have addition, subtraction, and also multiplication. So first of all, when we want to do addition matrix, you must make sure that the size match with each other. And then when you want to add them up, you need to add them up according to its entry. So this is entry row 1 column 1. You must plus with row 1 column 1 as well. Okay, so 5 plus 3. How about this part? Row 1 column 2 and row 1 column 2. So minus 2 plus minus 2. And this part here, 0 plus minus 3, 4 plus 1. So altogether, you will have a matrix as well with the same size, which is 2 by 2. Number 2 is example of subtraction matrix. So as usual, the size must be the same. So here, each entry will be subtract with its respective entry here. So 4 minus 12, 0 minus 5, 1 minus 6, minus 3, and so on. So we also have the results of the same size of matrix. So for example number 3, this is undefined, okay, no solution because the matrix size does not match. So you cannot do addition operation here. Now let's see for multiplication. Let's see two types of multiplication. One is when you multiply a scalar to a matrix. Another one when you multiply a matrix towards a matrix. Okay, when you want to multiply a scalar, you can do that, but you need to make sure you distribute to all entries. Okay, so 5 should be multiplied to all entries like this, and then you'll find the final answer. Next, if you want to multiply a matrix with another matrix, first of all, you must make sure that the size of matrix is matched to each other. Alright, for example, here you have 1 by 2 matrix, and then here you have 2 by 1 matrix. You must make sure that this size here is the same, so you can cancel out. So the final answer will be 1 to 1 matrix. Okay, so the way to multiply this is to multiply row with column. So first multiply 3 times 4 plus 5 times 2. So you'll find a matrix of 1 by 1, which is 22. Let's see this matrix here. Okay, example 5. This is matrix of 2 by 3 multiplied to matrix 3 by 2. Okay, so this size is matched, so we can cancel out. So the result will be a matrix of 2 by 2. So let's open up a matrix with entry of 2 by 2. And then in order to solve this, let's do this. Row 1 multiply with column 1. Put your answer here. Row 1 multiply column 2. Put your answer here. Row 2 multiply column 1. Put your answer here. And row 2 multiply column 2. Then this is the place. Okay, so as usual, we multiply and then we add them up. And finally, you can write the answer as 2 by 2. Alright, let's take note here that when you multiply a matrix A with matrix B, it is not the same with matrix B multiply matrix A, because this is not as simple as multiplying a scalar, where, for example, 3 times 2 is just equal to 2 times 3. It's not as simple as that. This is multiplication involving rows and columns, so it's very complicated. So make sure you know the properties of matrix. This is not the same. Another properties of matrix is when you multiply matrix A with I, with identity matrix, the answer will be matrix A. Okay, for this one, you can flip them. If matrix I times A, you also will get the same answer, which is matrix A. So we have demo here. Let's say this is matrix A, this is your identity. So when you multiply this up, you will find the same answer with A. So that's why A times I is equal to A. If you flip them up, I times A, you also get the same thing, which is matrix A. Now let's see other example here. Given matrix A, B, and C with different sizes of matrix. The first question asks you for B times A. So just take matrix B, multiply matrix A. So this is your answer. And then the next question asks you for matrix A times C. So this is matrix A, multiply matrix C. You can check the size. Okay, the size match with each other. Okay, you can cancel out. So the answer will be 2 by 3. Okay, so you have an answer of 2 by 3, meaning that 2 rows and then 3 columns. The next question asks you for A squared. Okay, be careful. For A squared, you cannot just take matrix A and you square each of the entries. Okay, it doesn't work that way. You need to take matrix A, multiply another matrix A, and then just do the multiplication rule. So lastly, you get the same size, which is 2 by 2. And again, you can try matrix A times I. Okay, just take matrix A, multiply matrix I, identity. You should get the same matrix A. Now let's see example 2. Given a matrix C, find the values of M and N such that C squared plus MC plus NI. What you should do is just open up the formula, and then for C squared, just take C, multiply another C, plus M, a scalar, multiply towards your C, plus N times identity equal to 0 matrix. Right? So all of the size here should be 2 by 2 matrix. So let's multiply C times C. All right? And then for M, multiply this C here, multiply M to each of the entries, and then for NI, just multiply inside. And then you can simplify everything. You'll get this matrix here. So in order to find M and N, as what the question wants, what we should do is we can just equate the matrix according to its entries. Okay, for example, the first one, 9 plus M plus N is equal to 0. The second one, 8 plus 2M plus 0 equal to 0. The third equation, 16 plus 4M plus 0 equal to 0. And the fourth one, 17 plus 3M plus N is equal to 0. So now you have 4 equations, so you can do simultaneous equation. So from 2, you can get straight away the value of M, okay, because in this equation 2, only one variable here, which is M, so you can just solve that straight away. So M is equal to -4. And then let's substitute M equal to -4 into other equation. For example, here I choose equation number 1. Okay, so we already know the value of M, so we can substitute it inside here. Okay, so M is -4, so let's substitute 9 plus -4 plus N equal to 0, and then just solve for N is -5. For example 3, you are given 2 matrix A and B, and then question asks you to show that AB is not equal to BA. So what you should do is just take matrix A, multiply matrix B, and then do the calculation. And then let's flip them up, matrix B times matrix A. So let's take B, multiply A, and then do the calculation. You'll get this. So let's just write that AB, this one, is not the same with B times A. And then since the question asks you to show, you must write here shown. So that's all for review matrix 6.1.